Welcome back to my YouTube channel. Today's LeetCode DCC question is bitwise AND of numbers range. So let's read the question. Given two integer left and right that represents the range from left to right inclusive, return the bitwise AND of all the numbers in this range. So what question is saying? So given a left value, let's suppose 5 and a right value, let's suppose 7. So what we have to return? We have to return the bitwise AND of 5, 6, 7. So we have to return this value. So how bitwise AND works? First, let's see that. So 0 and 0 will give 0 if we consider one bit number. 0 and 1, it will give 0. 1 and 0, it will give 0. 1 and 1, it will give 1. So basically, if we consider one bit number and we do a bitwise AND of one bit number, so if we get any number of times, if we get 0 any number of times, so like this, in this we have 2 times 0, in this 1 times 0, in this 1 times 0. So while doing the bitwise operation, if we get the 0 any number of times, then the value will turn out to be 0. And if we do a bitwise AND of all ones, then the value will be 1. And if any 0, any time 0, any zeros, then the value will be 0. So we will use this concept to find out the bitwise AND. So in our previous example, left 5 and right 7, let's see. So first we will write the binary of the numbers 5, 6, 7. So what will be the bitwise AND of this number 5, 6, and 7? So if we see the 0th bit, the numbers are 1, 0, 1. Since we have at least one 0 in this, the value will be 0, 0. Now we will use the first bit of all the numbers. The numbers are 0, 1, 1. Here also we can see we have at least one 0. That means the bitwise AND of all the numbers for this bit position, it will be 0. Now we see the third bit, 1, 1, 1. Since all the bit number is 1, so the value will be 1. So this value in decimal is 4. So we have taken this example only. We can see the output is 4. So we will use this concept. Let's deep dive into this pattern. So let's suppose we have a binary of a number, this. So we have written the binary of a number from 0 to 21, and we will try to observe some patterns. So if we see the 0th bit, so we can see the 0th bit, in the 0th bit, the values are repeating 0, 1, 0, 1, 0, 1, 0, 1. That means every two number, the pattern is repeating at 0th bit. Let's see at first bit. So we have two zeros, two ones. Again 2, 0, 2, 1. Again 2, 0, 2 ones. Again 2, 0, 2 ones. That means the pattern is repeating after 4 consecutive number. In this, the pattern was repeating after 2 consecutive number. Let's see for the second bit. In this, if we can see, we have 4 zeros, 4 ones. again 4 zeros, 4 ones, again 4 zeros, 4 ones. That means for the second bit, the pattern is repeating after 8 consecutive number. Like this way, we can see for third bit, the pattern will repeat after every 16 numbers. For the fourth bit, the pattern will repeat after every 32 numbers. And for the fifth bit, it will repeat after every 64 number. And how the pattern is, if the number is repeating after every two number, that means half of the number will be 0 and half of the number will be 1 for that bit position. Suppose if we consider the fourth bit, the pattern is repeating after 32 numbers. That means first 16 number will be zeros and then ones. 16 number will be 1. Again 16 number will be zeros. Again 16 number will be ones. Like this, the pattern will be repeated. So can we use this pattern to solve this question? Now, if we see how bitwise AND works. So in this pattern, so suppose for the fourth bit position, so the numbers are repeating after every four numbers, 0, 0, 1, 1, again 0, 0, 1, 1. So can we say at first position, if the numbers are repeating, if the pattern is repeating after every four consecutive number, that means if our range has more, if our range is greater than 4, that means for that bit position, for the first bit position, our value will always be 0. Since it, the range is greater than 4, that means we will definitely have two zeros, two ones in this pattern, in this bit position, in the first bit position. For example, if we consider second bit position, for example, if we take a number from range 3 to 7. So in this, we can see the range is greater than 4. That is the range of this number is 5. So from 3 to 7, can we see that for the first bit position, we will definitely have two zeros, two ones. See, we have 1 0, 1 0, 1 1, 1 1. Two zeros, two ones. Again, if we see any number with range greater than 4, suppose from 10 to 17, if we take. So if we take this range for the first bit position, we can see like we have the repetition two zeros, two ones. That means pattern is repeated. So can we say for the first bit position, for the 0th bit, if the range is greater than 2, that means we will always have the bitwise and 0. For the bit 1, if the range is greater than 4, that means we will definitely have 0 if we do bitwise and. For the bit 2, if the given range is greater than 8, that means the bitwise and of that range, and for that bit it will be 0, since the number will be repeated as 0 0 0 1 1 1 1. That means we will have four zeros, four ones. So let's draw a chart how it is working. So if we consider only four, any single bit, suppose currently we want to see for third bit. So for third bit, suppose for third bit, Can we say we have two options? Either the range is greater than equal to 8 or range is less than equal to 8, and here range is the range of right minus left plus 1. This range I am talking about. Right minus left plus 1. For the third bit, that's why we are considering 8. For the third bit, the pattern, sorry, for the second bit, let's see for the second bit. The pattern is repeating for the second bit is 4 zeros, 4 ones. That means after 8 number, the pattern is repeating. That's why we are considering range greater than equal to 8 and range less than equal to 8. If the range is greater than equal to 8, that means for this bit position, for the second bit position, the value will always be 0. For the second bit in the result, if we look at the second bit position, the value will always be 0. That is confirmed. Now, what is the possibility if the range is less than 8? So let's write the pattern. 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, and 0. Like this. So if the range is less than 8, that means we have 7 numbers. Maximum 7 numbers. So what can be the range of that number? Either from first 0 till 3 ones. That means the left and right. This bound, right, will cover some zeros, some ones, or some zeros, some ones, some zeros, some ones. Or if suppose the range is 3, then it may happen like the range is contains only all ones, or it contains all zeros, or it may happen like it contains ones to zeros, something like this. That means if it contains all zeros, then definitely the value will be 0. If it contains some zeros, some ones, then also the value will be 0, because any one zeros will result in 0 for the bitwise operation. And if the range lies in all ones, then the value will be 1. So let's take an example for another bit position. So this is 0th bit. So we have looked into second bit. Now let's suppose we look into first bit. Suppose we have looking into first bit position. So the pattern is repeating after 4 numbers, two zeros, two ones, right? That means if the range of the given input is greater than equal to 4, then definitely we will contain two zeros, two ones at least in the pattern. That means the bitwise AND will definitely be 0. And if the range contains less than 4 number, either it could be 1 number, 2 number, or 3 number. Like if it is 5 to 5, then it contains only 1 number. If the range is from 5 to 6, it contains only 2 numbers. If the range is 5 to 7, then it contains 3 number, like this. So let's write the pattern and how it is repeating. Two zeros, two ones. Again 2 0, two ones, like this. So suppose we have only one number in the range. Then that one number can either be 0 or 1. Suppose we have two numbers in the range. So either it contains both zeros or both ones or 1011 or 1011, like this. So if it contains both zeros, then the value will be 0. If it contains both ones, the value will be 1. If it contains some zeros, some ones, the value will be 0, right? So we will use this concept to solve this question. Let's take an example. Let's take some big example to solve this question. Suppose we have a range from 2 to, suppose 18. 2 to 18. From 2 to 18. So how many numbers we have in this range? We have 19 numbers, right? So if we see, we have to check the bits till, suppose we check till fifth bit. From MSB, if we check from 0th bit, 1 bit, second, third, fourth bit. After that, all the numbers till 31st bit, it will be 0, right? So the value will be anyway 0. So let's check from the fifth bit. In fifth bit, what will be the range of the pattern which is repeating? For the fifth bit, it will be 2 to the power 5 plus 1. That is 64. Means after every 64 number, our pattern will be repeating. And what is our pattern? 32 zeros and 32 ones. And how we are checking? So if we see, if our range is greater than 64 or less than 64. If it is greater than 64, greater than equal to 64, then that bit position will definitely be 0. Else, we have to see whether that range lies whether that range contains some zeros, some ones, or all zeros, or all ones. That we have to check. So since the range is 19, that means this scenario is not true. Either of this scenario will be true. So our number is from 2 to 18, right? And if we see, we have 64, right? And out of that, first 32 number from 0 to 31, from 0 to 31, it will contain zeros, and 32 to 63, it will contain ones. Since it lies in the range of 0, 0, because 2 is less than 31, 18 is also less than 31. That means this range contains all zeros. All zeros means in the resultant of this bitwise AND of this range, in the fifth bit position, we will get, in the fifth bit position, we will get 0. Now look at into fourth bit. So fourth bit. So what is the range after which the pattern is repeating for fourth bit is 2 to the power 4 plus 1. That is 32. That means first 16 number will be zeros. And after that, remaining 16 number will contain ones. And that means 0 to 15, it contains zeros, and 16 to 31, it contains ones. And our range was 2 to 18. So in the range 2 to 18, we will see, since we have completed the operation for the fifth bit, we will do one right shift. So after doing one right shift for 2 and 18, we will still be obtaining 2 and 18. So the range is still 2 to 18. So total numbers in this range is 19. So we will see whether that 19 is greater than 32 or not. It is not greater than 32. That means this range will contain either all zeros, all ones, or some zeros, some ones. So since 2 to 18, so 2 to 15, 2 to 15, it is zeros, and 16 to 18, it is ones. So we can see from 2 to 15 is zeros, and 16 to 18, it's ones. That means some zeros, some ones. And the bitwise end of this result will be 0. That means for the fourth bit also, the bitwise end for this bit position will be 0. Now, after doing this operation, we will do a left shift of this number. That means we will reduce the number by 2. That means we will ignore this bit now. Since the operation for fifth bit and 4 bit is completed, now are worried about only 3210 bit. So if we remove this bit position, let's suppose we make it 0 to ignore the impact of the fourth bit. So the number will be now in the range from 2 to 18 will change to 2 2, and 18 will change to 2. That means the number turns out to be 2 to 2. But the original range will still be same. That means we will still be having 19 numbers in this range. So we will use this. So for the next bit, now we will see into third bit. So our number 2 to 18 changes to 2 to 2, 2 and 2 after ignoring the fourth bit. But the original range will still be same. We will always use this range to check whether it lies in that particular range or not. Now for the third bit, so after how many numbers the pattern will repeat. For the third bit, it will be 3 plus 1. That is, after every 16 number, the pattern is repeating. That means first 8 numbers will contain zeros, 8 zeros, and then remaining 8 number will contain ones. Now we will see whether this range is greater than 19 or not. If the range, that means this range is 16, right? That means if we consider the numbers 2 to 18, and since the range is of the repeating of this sequence is 16, so 19 is greater than 16. That means any one time we will repeat this sequence of 8 zeros, 8 ones. So if the range is, since 19 is greater than 16, our bit value for that position will always be 0. That means for third bit also, the value is 0. Now, our value after doing the bit operation for 3, 4, it was 2, 2. Now, after the value 2, 2, after doing the bit operation third will be, since the value was 0, 0, 1, 0, and 0, 0, 1, 0. So we will remove this bit. Now again, the value is 2, 2, 2. Now we will see for the second bit. So our original value changes to 2 to 2, but range is still 19. That will never be changed. Now for the second bit position, 2, the pattern will repeat after 2 plus 1, that is 8. After 8 numbers, our pattern will repeat. That is, first 4 number will contain zeros and next 4 number will contain ones. So we will see whether this range is greater than 19 or not. So since our range is greater than 19, it will always be 0. Since 8 is greater than 19, it will always be 0. Similarly, for the first bit, if we see our range, number will range from 1 plus 1, that is 4. That means after every 4 number, our pattern will repeat. That is, first 2 number will be zeros and then 2 numbers will be 1. And since the range is greater than our original range is greater than this range, the bitwise AND for that number will always be 0. That means for the second bit also it is 0. For the first bit also it is 0. For the 0th bit also it is 0. That means the bitwise AND of the number from 2 to 18, it will be 0. So let's see whether it's like that or not. So we have any 1 0, that means it will be 0. In this also we have 1 0, that means it will be 0. In this also we have 1 0, it is 0. In this also we have 1 0, it is 0. In this range also we have 1 0, that is 0. In this range also we have at least 1 0, that is 0. That means our bitwise AND operation for this number will be 0. Let's take one more example. Let's take, for example, let's take the range from 4 to 4 to let's take the range from 4 to 7. Or let's take the range from 12 to 15. Let's take this range. Or 12 to 17. Let's take this range from 12 to 17. So the numbers, total numbers in this range is 6 numbers. Total 6 numbers are there in this range. So let's see. So beginning from the fifth bit. For the fifth bit, our number is, the pattern repeats after 2 to the 5 plus 1, that is 2 to the power 64. 6, that is after every 64 number, a pattern is repeating. That means first 32 number will be zeros and next 32 numbers will be 1, right? Yeah. So our actual range is 16, and this for the fifth bit position, the pattern repeats after every 64 numbers. That means since 6 is less than 64, we have to see. So it will, we can't say whether it will be 0. Now we will see. Now that means it may contains all zeros, all ones, or some zeros and some ones, right? So so and the range of zeros will be from 0 to 31, it will contain 0, and from 32 to 63 it will contain ones. So we will see our range is from 12 to 17. That means it lies in this range 0 to 31. That means all zeros. Since 12 to 17, the fifth bit position is all zeros, the bitwise AND of that number will be 0. That means for the fifth bit position, the resultant bitwise AND of this range will be 0. Now let's check for the fourth bit. For the fourth bit, for the fourth bit, for the fourth bit, our pattern will repeat from 2, 4 plus 1, that is 32. That means first 16 number will be zeros and next 16 number will be ones. And it's range from 0 to 15, and this range from 16 to 32, 31. And after completing the operation for the fifth bit, we will remove that fifth bit from this number. So after removing fifth bit from the number, so it is still, after removing fifth bit from the number still remains the 12 to 17, right? Now, since the range is 32 and our actual range is 6, it is less than 32. That means it may contain some zeros, some ones, or some zeros, some ones, like this. Let's see. So our number lies from 12 to 17. That means for the number 12 to 15, it will be zeros. And from 16 to 17, it will be ones. That means it lies in this some zeros, some ones. So bitwise and for this condition is also 0. That means for fourth bit also the resultant will be 0. Now after completing the operation for the fourth bit, we will remove the fourth bit from this number. So after removing the fourth bit from this number, 12 to 17, we will get 12 to 1. So the number is 12 to 1. Now let's see for the third bit. So our third bit ranges from 2 to 3 plus 1, that is 16. That means first 8 numbers will be 0 and next 8 number will be ones. So it is 16. Now our actual number range is 6. So 6 is less than 16. That means it may contain some zeros, some ones, or some zeros, some ones. So we will see whether this range contains some zeros or some ones. Now, if we see our number has been changed from 12 to 17 to 12 to 1, that means it will definitely contain some zeros, some ones. Since what we are saying, our pattern is like this: 0, 0, 0, and then ones. That means all the zeros will complete and then one will start. And since the number is the starting, the left number is in itself 12, that is greater than the right number. That means the pattern is like some ones and then zeros. It lies in this range. That means definitely it contains some zeros, some ones. So it will also be 0. For this bit also, the value turns out to be 0. So we will remove the third bit from this number. So after removing the third bit from this number, 12 to 17, the number turns to be 4 to 1. So the number will change to 4 to 1. So if we will see for the second bit, the number ranges from 2 to 2 plus 1, that is 3, that is 8. So our first four number will be zeros and next four number will be 8. First four number will be zeros and next four number will be 1. And the actual range is 6. Now our number was 4 and 1. So left becomes 4 and right becomes 1. So we will see our actual range, that is 6, is still less than 8. That means it still contains some zeros, some ones, or all zeros, all ones, or some zeros, some ones. Now, since after removing the fifth, fourth, and third bit from this range, our number is looking like 4 and 1. That is, left is greater than 1. That means it will contain some, it will definitely contain some zeros, some ones. If this, why it is so? Because if the number 4 contains ones, if the number 4 contains ones, and if it contains all, if this range contains all ones, then this number should, then the right number should definitely be have been greater than this 4. But since this number is less than 4, that means it is a pattern like some 0, 0, 0, 1, 1, 1, 1, again 0, 0, 0, 0. That means it lies in certain range like this: 1 and then zeros, or some ones like this 0. Means the left lies in this 1 part and the right lies in this 0 part. So it is also 0. That means for the second bit also the number will be 0. Now, since we are done with the second bit operation, so we will remove the second bit from the number. So after removing the second bit from the number, our number will turn to be 0 and 1. 0 and 1. So for the first bit, now our ranges, our pattern will repeat after 2 to the 1, that is 4, that is first two number will be zeros and next two number will be ones. Since 4 is less than 6, that means 6 is greater than 4. That means our this pattern, two zeros and two ones, will definitely be repeated. So since it is repeated, so the number, the bitwise end of this number in this range will be 0. So for the first bit also, our number will be 0. So after, since we are done with the first bit operation, we will remove the first bit from the numbers, and number will be, after that number will be 0 and 1. So the number becomes 0 and 1. That is, our left is 0 and right is 1. Now for the 0th bit, for 0th bit, the pattern will repeat after 0 plus 1, that is 2. That is, first one number will be 0 and next one number will be 1. Since this is 2 is less than 6, that means definitely this pattern has been repeated in this range, in this original range. That means the bitwise end for this number will be 0. So again, it is 0. Since all bits are 0, the bitwise end for this number will be 0. So I hope we are clear with the solution. Let's try to code. So let's take a variable to keep the answer. Now we will find the actual range of this number, total, or we can say actual range of this number. Actual range of this number will be right minus left minus 1. This is the actual range. Now, so what we have seen, we will repeat that operation for every bit. So from 31 to greater than equal to 0, I minus minus. So that for that bit position, the range will be, that means that bit range will be pow 2 comma I plus 1. So that means after this pattern, after this number, means that means after this bit range, our pattern will repeated. Now, what is the half of that number? We will find the half of this number. It will be bit range by minus 1 by 2. So this indicates from 0 to half, our number will be 0. So this indicates from 0 to half, our number will be 0. And from half plus 1 till bit range, our number will be ones. So we will check that conditions. So since we have calculated, now we will see if the actual range is greater than, if actual range is greater than bit range, that means this pattern must have been repeated, must have been repeated. So in this case, our bitwise AND operation for that particular bit will be, or that particular bit will be 0. Else, if it is not repeated, we have to find whether the case lies, we have 4 cases, right? Either all zeros, all zeros case will occur if the left and right both is less than equal to half. All ones will arise when left and right both is greater than half. Some zeros, else it will contain some zeros, some ones, or some zeros, some ones, right? Or if what we in one scenario we have seen, like left is greater than right. In that case also, that means our pattern is like for there are some zeros, some ones, and after that again some zeros. That means it is lies in this range. Still, it will contain some zeros, some ones. So 4 cases. So we will write else if left is greater than right. Our answer will be answer into 2 plus 0. Else if our left is greater than half and right is also greater than half. That means that range contains all ones. In all ones case, we will add 1. Else, else it means it contains either all zeros or some zeros, some ones. In that case also, we will write sir into 2 plus 0. And once we are done with this bit operation, we will remove the bit. So how we are removing that bit? So we will do AND operation of that bit with number what? We will do the AND operation of that for that particular bit will be with 0. So we will negate the number and do right shift of 1 with I. So this will negate the number and will negate that bit position if the value at that bit position at the ith bit position is or the ith bit position if the value is 0, then 0 and 0 is 0. If it contains ones, then also 1 and 0 is 0. And for the remaining since we are negating, so ith bit will contain zeros and bit right to that ith bit it will contain 1. So this complement of 1 left shift I. So for the remaining bit, we are doing the bitwise AND with 1. So it will give, if it is 0, it will give 0. If it is 1, it will give 1 like this. Right? And we will negate it. I. And then our bitwise AND result will be stored in answer. Mm. I hope this solution works. There is some, let's see. So we have find the actual range and then we are iterating from 31st bit till second bit, correct? And then we are finding the actual bit range after which the number is repeating, that is 2 comma I plus 1, correct? We are finding the mid way of that pattern, that is bit range minus 1 by 2, correct? Now we are checking if actual range is greater than equal to bit range. If that is so, the answer will be 0. Else if our number left is greater than right, if left is greater than right, then also our answer is 0. Else if left is greater than half and right is also greater than half, then it is 1. Else that means both the range lies contains either all zeros or some zeros, some ones. And then we are doing a left shift of 1 and doing the AND operation. Mm, What is left is greater than right? Since we are doing the same operation here, we can merge this two also. Or we can say like this, or left is greater than right. And we can remove this. And else if left is greater than half and right is greater than half. Correct. Half range is bit range. Suppose I value is 3, then our bit range will be 2 to the power 3 plus 1. It will be 16. Now half range will be 16 minus 1, 15 by 2. That is 7. It is correct. 0 to 7. And then 8 to 15. Correct. And if actual range will be right minus left plus 1. Sorry. Here it will be plus 1. And since our actual range is greater, let's try to submit. Yeah, now it is accepted. Let's try to submit the test cases. Yeah, it is accepted. So what is the time complexity of this solution? If we see, so what we are doing, this will take O1 operation, O1 time. So we are running the for loop from 31 to 0, that is 32 times, that is O of 32. And for each for loop, what we are doing, we are calculating the power, that is some mathematical operation, half, this is some checking, and this is some bitwise operation. So it is somewhere taking some constant time. So can we say we are taking 0 of 32 into 0 of 1 time, that is 0 of 32 time. So can we say our solution is taking more or less constant time? So, so there is one more approach. If we see, so this solution is taking, so doing manipulation, it will take some constant time. Or we can do like left, if left is 4 and right is 16, so we can do bit running for loop from 4 to 16. We can do bitwise AND of 4 plus 5, 4 and 5, like this till 16. So this is also one solution, but it will take, the time complexity of this solution will be O of this range. And if we see, the range given is, and if we see, the range given is 2 to the power 31 minus 1. That is, it will take maximum of 2 to the power 31 time. That is nearly equal to 10 to the power 9. So, so this solution may give TLE. I hope my solution is understandable and it is taking constant time. Meet you in the next video. Thank you.